Hello, my name is Colin, and welcome to part 19 of Let's Build a 2D Platformer in the Godot game engine. In this tutorial, not so mini series, we're building this 2D platformer video game. Of course, in this game, you control a little player on screen using the keys on your keyboard. Of course, in this game, you can walk and run and jump and fall and explore a large level. You can collect coins, jump on and squash enemies, get hurt by enemies, and in this tutorial, we're going to be adding shooting fireballs. Of course, if you have not seen the rest of this whole tutorial series, you can go ahead and start from the very beginning and follow along creating this game with me step by step. I'll go ahead and put a link up on the screen right now that you can click on so you can go ahead and check out this tutorial series playlist here on YouTube on my channel. As it stands in my project right now, if I go ahead and press play scene with my level 1 scene active, my game launches. Of course, I have a little character on screen that looks like it's walking around. As of the last video in the series, if I go ahead and press the letter Z on my keyboard and hold that key down and move left and right, I can accelerate up to a run. And if I'm running, well, actually right now there's a little bit of a problem. If I run to the right and I jump when I'm running, well, the amount of acceleration or deceleration that happens when I jump actually isn't consistent. I made a little mistake in the last video with how you decelerate from a run. If I jump to the left, if I run and then jump, you can see that I slow down quite quickly when I was in the air. So we have a little problem to tackle with actually just one character to flip over before we get into creating fireballs. If I go to my player, my little Steve character's code, so down here in my scene dock on the left-hand side of my screen, if I click on my little Steve's character here, in the last video in this series, I'll go ahead and maximize my code on screen and hide this output at the bottom. We made a finite state machine in our character's code to help our character's code be organized. In the last video, we added what's called a match statement with two states. We have an air state with code right here, and we have a floor state. So we have two different states that our character can behave differently and can be controlled differently if they're on the floor, which is from here all the way down to right there in our code from the air. What happens though, the problem in our game, and thank you to the user, the Godot user, the viewer on my channel named Gilead Marilyn, I believe their name is, who pointed out my mistake, which is in the air state of my character. We have this code that I tried to carefully construct in the last video in this series, where if you're pressing right or you're pressing left in the air, so in this air state, you have this ternary operator, basically an inline if statement, which controls how you decelerate or accelerate using, I'll go ahead and zoom out on my code just a little bit so we can see it all in the line. So I'll press Control minus a few times all in one line. We are basically decelerating or accelerating at different rates based on how you were moving before you pressed jump. Now, in line 22 of my code, I have a less than symbol, and in line 25 of my code, when you're moving right versus left, I also have a less than symbol. It turns out that my acceleration deceleration problem is just a flipped over symbol right here. So if I change this less than to a greater than, just like that, if I go ahead and press Control S to save and I go up to play scene with my level 1 scene active, well, that fixes the problem. So now if I'm running, I'll go ahead and run to the right and I jump. Well, I'll decelerate at the same rate in the air, whereas if I jump to the left, it now acts properly. It doesn't slow me down too quickly. That's that fix. Thank you again to that user who commented on my previous video. So in this video, we're going to tackle adding fireballs. Fireballs that can bounce, fireballs that you can shoot from your little character on screen, left and right. They will kill enemies. They'll play a little sound whenever you shoot. Let's go ahead and jump into that. Before we can actually start coding this feature in our game, let's go ahead and minimize the Godot editor, because on my desktop, there is a little picture called fireball.png. If I double click, you can see what that looks like. It's a little PNG picture with a transparent background. That's what that checkerboard picture graphic is. I'll go ahead now and copy that file. By the way, if you want this file, I'm giving it to you. It's a picture that I got from kenny.nl. They are not a sponsor. They just give away lots of free graphics. They also sell packs of awesome assets for game making. It's a great site. Go check it out. Let's go ahead and copy that file. I'll right click and copy. I'll go into my project folder, go into my assets folder. And right here, I have all of my sprites, all of my sounds, all of my fonts. I'm going to make a folder. I will click new folder. And I'm going to name this folder projectiles, and I'll press enter. So in that projectiles folder, I'll go in there, I'll paste my fireball.png. That's as good as gold. Let's go ahead and close that. I'll go back into my Godot editor. It will import that picture automatically. I don't even see the scroll bar go past to import. It just does it automatically. So down here in my file system dock, by the way, I am always going to be maximizing my middle workspace with this button so it hides the sidebars, and then I'll quickly bring them back using that button there. That's what I'm doing. So over here in my left bottom file system dock, if I open up the assets folder, you can see I now have that projectiles folder from my project folder, and there's fireball.png. The other thing we have to do is set up a key on our keyboard to fire with. So I'm going to go ahead and bind a key on my keyboard to what's called an action in Godot. If you've been following along with this whole series, you'll know what an action is and how to set it up. Let's go ahead and go up to the project menu, go to project settings, and then go to the second tab here called Input Map. At the bottom of our Input Map properties, you can see all of the actions that we created earlier in this series, like left and right and jump and run. We made this in the last video. Let's go ahead and make a new action up here. I'm going to call it fire, F-I-R-E. I'll press add. There it is right there. We haven't bound it to any keys on our keyboard, so I will press this little plus right there. I will choose key. They added this physical key option. I'm still not quite sure what it is. I haven't kept up with this latest development, but we'll just use a key. And I'm going to press the letter V on my keyboard. V for fire, because, well, I have the letter Z on my keyboard for run, and V is the pointer, my index finger on my hand. So Z uses my pinky finger, and F uses my, V on my keyboard, it uses my index finger. If I press OK, that will work. But in my demo game at borncg.itch.io, I use the letters A and F on my keyboard to run and fire. So I'm going to set those up right now as alternate keys. So you can press either Z or A to run, or V or F to fire. So I can just add another key to each. And for run, I'll use the A key as an option. So it's either or of these two keys. And same thing for fire, I will use a key and F. So let's go ahead and press close. I've got my key binding set up. Whenever you make an object in your game in Godot, you make a new scene. Our little character is its own scene that we have an instance of in our level scene. And our enemies are also a scene. Our coins are also a scene. So it makes sense that objects that we spawn while we're playing our game, like we create new instances of our fireball as the game is actually running, is going to be its own scene. So I'll press this plus button up here. Just like our enemy and just like our character that we control, whenever you have a physics object in Godot that you want to program the movement of, you want to start that scene usually with a kinematic body 2D in a 2D game. So over here in my scene dock, I'm going to press the plus button. I'm going to add a kinematic body 2D. This is the same as our character and our enemy, just like before in previous videos. So I will double click on kinematic body 2D after searching for it. I'm going to name this scene, or the root node, pardon me, Fireball. And to that, I'm going to add two child nodes. Of course, you should know what these are. These are going to be our collision shape 2D as well as our sprite. So I'll select that node. I'll press plus. I'm going to search for sprite right here. I'll double click. And I'm going to select the root node again. I'll click right there and press plus. And I'm going to add a collision shape 2D. If I search for collision, it'll select collision polygon. I don't want that. I want a collision shape 2D, just like that. Okay. Make sure, if you're new to Godot, that you're making sure that these two nodes are both directly children of the root node. If you accidentally, have a system like this or a setup like this, where the collision shape 2D is a child of the sprite because it's indented more, you can just drag the collision shape 2D onto what you want to be its parent, like that, and that fixes that. Okay. The sprite, if I select that node, of course, if I go over to the inspector, I need to give it a texture. I'll go ahead and drag my fireball texture into that texture empty slot with that sprite selected. Now, when you create a new scene and you're setting up the object, leave everything at the 0, mark in your game. Don't drag things around and make it over here. You want to leave it where the two lines intersect in Godot's interface at the top corner of the game rectangle. Okay, that's at 0. That'll work best. I'm going to go ahead and give this shape a actual shape so it can collide using a circular shape. So I'll select that shape, 2D collision shape, and I'll give it a shape. I'm going to select over here a circle shape 2D. And so that's that. I can zoom in and drag the little pink handle here to make it a little bit bigger. I'll make the sprite, the orange color, a little bit. I'll press Control Z. I accidentally dragged it there. I'll leave the sprite a little bit bigger than my collision shape, just a tad. I think that looks good. So I'm going to press Control S on my keyboard to save this scene. When I do that, it'll save it into my project folder. It'll name it the same as my root node, Fireball, good.tscn, good. I'll press save. A couple more things before we can start coding this and actually make it work. Number one is I need to add a script file to my root node. I want to program the movement of this Fireball object. So I'll select the root node. I'll press the plus add script button right there. It'll make a new GD script file. That's what I want. I'm going to make it have the default template. Actually, I'll change this to the empty template so it doesn't give us so much extra commenting. That's a better default template to use. And it'll be called fireball.gd in my project folder. That's fine. I'll press create. Here is my code file. Before I start typing my code, one last thing. I'm going to press Control S to save it. You can tell when something isn't saved when it has a little star or asterisk in brackets there. So I can click there and Control S to save that. In my Fireball scene, I'll go back to my 2D workspace into my Fireball scene. We need to set up the object's collision layers and collision masks. You'll recall in previous videos, we always made sure that we sorted out all our categories of objects into different collision layers. It's not the first collision here. When I select my root node, it's the second collision section right here with all of these squares with numbers on them. The collision layer lets you categorize this type of object. So we named these earlier on in the series. If I click this little little ellipses button here, you can see right now my Fireball is on the player layer. We named these earlier in the series: player, platform, fall zone, item. I'm going to uncheck player because we want the Fireball to be on the Fireball layer. That's what we want. Okay, so if I go ahead and just click somewhere else in my interface, it's on layer 6 now. By the way, in previous versions of Godot, earlier in this video series, these buttons look a little bit different, and so they've changed and been updated in this newer version of Godot. Right now, by the way, I'm using, under the help menu about Godot, I'm using Godot 3.4.3. I'm not quite sure if that's the latest version, but it should be pretty new, okay? So these layer buttons have been rearranged, and they look a little bit different, very slightly. They have these numbers in them now. It's fine. They're all the same. They work the same way, okay? The mask. We want this Fireball to detect other parts of our game, other categories of elements. So if I click the little ellipses next to mask, I want the Fireball not to be able to hit players. Nope. I want Fireballs to only be able to hit platforms. I want the Fireballs to bounce off of platforms, so they need to know that platforms are there and they can collide with them. So that's it. Now you might be thinking that you want your Fireball to detect enemies in your game. Well, actually, no, you don't. You want enemies to be able to detect fireballs, not the other way around. And that's how we're going to do it in this video. So just mask layer 2 right now so it can detect the platforms in our game. Okay, that's that. I'll press Control S on my keyboard and I'll go back to my level 1 scene. If I play my game right now, I want to press the letter F or V to fire, and those don't work. And this is going to be the first time in this series that we're actually not going to add instances of an object in our game directly to our node tree structure over here where all of our other objects are, because we don't want to have any fireballs in our game right when the game first loads. We want to make them dynamically added to this tree, but only when the game's actually running. And we want to be able to have as many fireballs shooting in our scene as we want whenever we press the F or V key or our fire action key on our keyboard. So this requires coding and adding objects into our game dynamically, kind of in real time during the runtime of our game for the first time in this series. How do we do this? Well, this is all going to be done in Steve's code. So I'm going to go ahead and go to Steve's code, and I'm going to go up to the top, and I'm going to add a new constant where we're going to actually preload the fireball scene as kind of a resource in our game's memory, so that when we actually press the fire key on our keyboard, it doesn't have to wait in order to load. We've already preloaded it. By making a constant called fireball, I'll go ahead and type const fireball, and making that fireball variable equal to a pointer, or it'll be a pointer basically to a preloaded resource, we can then create instances of this constant fireball. So right here, constant fireball is going to equal, and I'm going to call this preload method that's built into GD script, and it's a method, so I got to put round brackets here. When I want to preload an object, basically I just have to point to its path. So over here in the file system doc, I can collapse my assets folder because I want to preload my tscn scene file, fireball.tscn. So I'm actually going to select that file, but right in these round brackets, I need to copy and paste the path right here, which starts with res:// and then the file name. So I'll copy that, Control C. I'll add some double quotes into this preload method being called, and I'll paste the path, oops, just once. Okay, I'll press Control C to undo that. So we've preloaded the fireball. And if I want to actually shoot the fireball, well, I have to have an if statement in my code that says, if I press the fire action key, well, make a new instance of the fireball. When are we going to allow our character to shoot a fireball? Well, can my character shoot while they're in the air? Well, for me, this is up to me. This is my game. I believe, yes, you can. You can shoot while you're in mid-jump. Can you also shoot when you're on the floor? Yes, of course. So we're not going to duplicate all of our code for shooting in both of the sections of our states for, well, right here in this selected code, as well as down here from there to there. Instead, we're going to separate all of the firing code and the code to detect if you're actually pressing the fire key on your keyboard into a separate function, which will actually live just down here. In fact, I'll make it right now. Func fire, round bracket, colon, and all of our detection for pressing the fire key and all of the actual creation of instances of our fireball will go down here. And in our two states, I'll let you pause the video if you need to get that code, copy it down if you're following along. Up in my two states, I'm simply going to call this fire function, and that means that code in the fire function that we're going to write will be reusable. So right up here in my air state, if I press enter at the end, I'm still indented inside of lining up with all this other code. Right here, I'll type fire. I'll call the fire function that we're about to write. Same thing right down here in my floor state. I'm going to go right below this move and fall method or function call. I'm going to call fire right there. Okay, so now it'll check 60 times per second because those two states are in my physics process delta function. It'll check to see if I'm firing 60 times per second, which is fine. So I'm going to go ahead and actually write this code. When I press fire, or actually when I call my fire function, I'm going to check to see if I press the fire action. So I'm going to say, I have to be indented here, of course. So I've got this little icon here. That means I've pressed tab. I'm going to say if input.is action just pressed. I'm going to use the just version here because I don't want to be able to press the fire key and hold it down and shoot like a machine gun. No, I want to have to press the fire key each time I want to fire a distinct fireball. Okay. When I just pressed the fire action, I'll put a colon right there. I want to create a new instance of that constant called fireball. So I'm actually going to make a new variable. It's going to be called varf. And I'm going to make it equal to, it's fireball for short. I'm going to make it equal to our constant, which is fireball dot instance. An instance is a function or method that you can call that creates an instance of a preloaded resource. Aha. Now, is this all you need? Well, no, because this instance is actually not yet in our tree structure of our level. It's actually not in our level yet. It's just a copy or an instance or a use of this fireball scene in our game's memory, but it hasn't been added to this scene. Now, there is a method that you can call called add_child, and add child essentially adds a new node or a resource that you've preloaded and you've made a new instance of into your scene as a child of whatever object this code is on. This code is on Steve. So if I say add child and I say F, well, that's going to add a new fireball to my scene as a child, just like this camera, to Steve and put it in my scene. In fact, if I go ahead and Control S to save, and with level 1 scene selected, I'll press play scene. I'm not quite sure what's going to happen here. My game loads. If I tap F on my keyboard, I get a new fireball in my game, and well, it's following along with me. So I don't want that. I want it to be separate from me, so when I fire it, it's just in my game and it's not stuck to me. By the way, my camera is stuck to me too. That's why, because my camera is a child of my character, that's why when I move, the camera follows me, okay? So I'm going to say not just add child, but I'm going to select Steve's parent. And I'm going to say, hey, add a child to the parent of Steve, which is the root node of my whole level. So I'm going to say, before add child, I'll say get underscore parent, bracket, bracket, dot add child. So now we're getting the root node of my scene up there because Steve's a direct child of the root node of the scene. And I'm going to say add child to that. So now if I press Control S to save, and of course you can pause the video if you need to catch up typing this code. If I press play scene and I load my game and I tap F or V on my keyboard, it makes a fireball. Or does it? Well, yes, it did, but it's not anywhere I can see. In fact, it's at the root or location of the root of my root node, which is actually somewhere else up above where you can see right now. So if I actually walk, I actually know where it is, and I'll show you how to find this. If I go up to a platform and then jump back up, it's right there. Do you see it? Right there. So that's where 0, 0 is in my scene. It's where my root node actually is. If I stop my game and go back to my 2D workspace, you can see that if I select that root node, my little plus, my little cross is right there. That's where that node is, okay? So it goes there. I don't want that, so I'm going to go back to Steve's code. I'll jump back and click on his little code icon there. I'll maximize my workspace and close this output at the bottom. What I want to do here is once I've now added F into my scene, I'm going to move F, my current fireball. So I'm going to say F dot, and now I can access F's properties. I'm going to say F dot position, and I'm going to say F dot position dot, and now I can say X or Y because position is a property. It's actually a vector 2 of the object, and you can relocate it. So I'm going to say F dot position dot Y is going to equal my character, Steve's Y, which I just have to type position dot Y for because I don't have to type its name because we're on Steve's code. So make the fireball's position.y up and down location equal to the y of this current object that we're on. I'll do the same thing for x. So f.position.x equals my position.x. And so now the fireball should go exactly to where my character is, wherever my character is. I'll go ahead and press Control S to save. I will press play scene with my level 1 scene active tab there. And now if I press F or V on my keyboard, hey, I've shot some fireballs in my game. Now, obviously they don't move, they don't go across the screen. Let's go ahead and fix that. By the way, if for some reason a fireball touched an enemy, I'll go up and leave one right there. Does the enemy touch it? No, it would actually crash my game right now, and we'll cover that later in this video. It'll be right after we start coding some movement on our fireball. So I need to go to my fireball scene and make it move. So I'm going to go to my fireball.gd script, or you can go to your side. Actually, we can go into and find in our file system doc our fireball.gd script file. So I can just find it right there and double click on it to go into it. What we have to do here is treat this fireball kind of just like an enemy or like our Steve character itself. It's a kinematic body 2D object. So I'm going to go ahead and give it some variables to help us actually make it move. You might be guessing what we're going to add, and you might be right. We're going to go ahead and add a variable called velocity. Velocity is going to equal a vector 2. If this is looking familiar, it should, because we had a velocity both on our Steve character and on our enemy. So it'll be a vector 2 just like that. We're also going to add a speed, and this is just like our enemy. So I'm going to make a constant this time our fireball is going to have a constant speed. We don't have to change it after we make the speed, so I'll make it a constant. When you name a constant, it'll be all capital letters. That's kind of a convention. And I'm going to make the fireball shoot at 800 speed, and that works for me. We're also going to give our fireball a direction. So I'm going to make a variable called direction. And if you recall, our enemy has a direction as well. Our enemy, if I quickly go back to my 2D workspace, can move left or right based on the direction that we give it, which is 1 for right and -1 for left. And so our fireball will look, when we shoot it, at how our sprite of our character is facing, right or left, and it'll make that direction 1 or -1. Okay, so let's go ahead and do that. I'll go back to my script of my fireball, and I'm going to make the direction default equal to 1. Okay. Now, we're going to add some more variables and constants a little later on. In fact, I'm going to group my variables together. I'm going to cut that, Control X, and put it up here. So my variables are up top and my constants are down below. That's just my preference. I'm going to go down and now implement a few functions in this code. I'm going to make a function called _ready. This is a standard function that actually gets called whenever an object first gets put into or loads in a game. This happens when the fireball first gets created and you add it into your game. So at that time, we're actually going to set our speed, our velocity. So I'm going to say velocity dot x. We're just going to worry about the x velocity right now, how fast you're moving to the right or left, is going to equal the speed that we set up top, our constant, times direction. And the reason we're doing this is because direction will equal 1 or -1. And we want our fireball, our velocity.x, to move at either 800, which is 800 times 1, the direction, or -800, which will be 800 times, if our direction is -1, and we'll set that in our code when we fire, it'll be -800 if we're facing to the left. Okay? That's everything that goes in our ready function. Next up is that function. It's called physics process delta. So func _ physics process delta. You've seen that many times before at this point in this series. This is our game loop, our 60 times per second, forever looping, checking code. 60 times per second, I'm going to go ahead and make my fireball move. So I'm going to call the move and slide function, and we're going to give it a velocity. And that should pretty much do it to make it move. But actually, I'm going to go ahead and put this in here right now. I'm going to make my velocity be updated in case our fireball hits anything else. We'll say velocity equals move and slide velocity. Essentially, if your object is being moved by move and slide, and the movement is influenced by other objects in your game, like hitting a wall or deflecting off of something, well, move and slide will update your velocity by returning a value, and we'll save it back. So it's a kind of nice way of just cleanly making movement, but also updating your movement in real time. Okay? Now, we'll make this code, this line, be last in our game loop, because I'm going to say right above that, if our fireball hits a wall, we're going to make the fireball vanish. We're going to destroy it in our game and remove it from our game. So I'm going to say if is on wall, this is our fireball. If it's on a wall, it's a function, so we have to put round brackets there and a colon. If we're on a wall, we're going to call queue_free. Queue free is the method that you call that destroys the object. It removes it from the game. That's what we want, except that if we check if the fireball is on the wall, it needs to know what a wall is, what directions walls face as opposed to a ceiling or floor. That is done. We have to tell our game, this object, which way is up down here as the second parameter of this move and slide method. So we can put comma right there and say vector2.up. Up is a constant that's built into the vector2 class. It's basically just saying, hey, up is up. And so now if on wall is called, it should work. Let's go ahead and see what this does. If I press Control S to save and I press play scene with level 1 active up there, this tab, if I press play scene, if I go ahead and tap F on my keyboard, hey, we have a shooting fireball. If I press left on my keyboard to face the other way, Does it work? Well, it doesn't. It fires the original direction. Also, you'll notice that the fireball shoots from the middle of my character. So let's go ahead and fix a few of those little issues. By the way, if you're going to fire, if I jump and I fire and I happen to hit an enemy, my game will crash. We haven't prepared our enemy to detect properly our fireballs, so don't worry about that. We'll fix that in just a moment. I accidentally added an F right there in my code, so I'll delete that. Be careful about that, okay? In my enemy's code, not my enemy's code, I'm going to go back to my fireball code. Actually, you know what? I'm going to go back to Steve's code, because Steve is where we're actually telling the fireball to be made and be added to my scene. Right here on my line 72 and 73, we've said, hey, put the fireball that just got created at my position X and Y. I'm actually going to change the X a little bit, because we want the fireball to go off to my little Steve's right-hand side if we're facing to the right, and to the left if we're facing to the left. So in my code, what I'm actually going to do here is make a new variable called direction that looks at my sprite direction of Steve. We actually don't have a direction variable for Steve. This is the Steve code that we're on. We have a lot of other variables, but our direction was just for our enemy and now for our fireball. So the only way of knowing if our sprite of our Steve character is facing to the right or left is if I go into Steve's scene right here, I'll click on this little icon, is if this sprite has this flip H on checkbox. If it has it on, it's facing, my Steve character is facing to the left. If it's not turned on, which is the default, Steve is facing to the right. So what I need to do here is just make a temporary variable in Steve's code that looks at this flip property of the sprite and determines a direction that we should be assigning to the direction of the fireball. Makes sense? If it doesn't, just follow along. Let's go ahead and jump back into Steve's code, because down in, I'm going to go down to that fire code, we're going to make, when we press fire, a new fireball. But actually right before that, I'll press enter right there. We're going to make a variable called direction. And this direction variable will be remade every time we press fire, just like we make a new variable F every time we press fire. We're going to make a variable called direction, and we're going to make it equal to either 1 or -1 if our sprite is flipped or not flipped. This is a perfect use for the ternary operator, the operator that lets you have an if statement in the same line to give two different results if that condition is true or if it's false. We did this in the last video to create that acceleration up and down in our code. In fact, the ternary operator is right here. It's where you have an if and you assign two different things, if and else. You can assign right there to a variable. We're going to do the same thing. We're going to make the direction of the fireball set by this direction that we're making in Steve's code. Let's go ahead and do it. Okay, we're going to say if, and I'm going to go ahead and grab my sprite. So I'm going to say $sprite. This is the name of my sprite that's a child of Steve's root node. We're going to say if sprite.flip_h is equal to true. Actually, we're going to make it if not flip h, because right now I'll say if not flip h, or sprite.flip_h, because if I go back to the way that Steve looks and I go to his properties of this sprite, that's the $sign sprite that we just typed. If I go to its properties, if this flip h is not on, that means it's false. I want to make my direction equal to 1. And if this is on, if it's true, I'm going to make the direction equal to -1. So in my Steve's code, what I'm doing here, I'll maximize my workspace, is if not, if this is false, in other words, I'm going to make direction equal to 1. So if not sprite flip h, direction should equal 1, and I'm going to put else -1. Actually, I realized that I put this 1 in the wrong spot. I'm going to go ahead and cut it, and I've got to put it right over here. So make direction equal to 1 if the condition goes right after. I'm getting my languages confused. I've been typing a lot of Java in my other life, so I've been putting the other value later on. But in GD script, well, we put the first value first, and then we say, hey, assign direction to 1, and then we put the if after, and we're putting the condition right after the word if not sprite flipped, and then we're putting an else and the -1 right there. So direction right now, as of this code, will be 1 or -1 based on the sprite. What do we do with that? Well, before we actually add the fireball into our scene as a child of the root node of Steve, we're going to go ahead and make our fireball's direction equal to this method's or this function's local direction variable. So right before we add the f as a child to the scene, I'm going to say f.direction is going to equal my direction. So f.direction equals direction, just like that. Also, we're going to use this direction variable to either add about 25 pixels to the position.x of the fireball, or subtract 25 pixels to make it go to our right or left. So we're going to make the fireball, or f.position.x, equal to my position plus, I'm going to say 25, and I would be very careful about this number. I would use a low number like me, not 40 or 50 or 60, and then say times direction, because direction might be 1 or -1. And if it's 1, well, it'll be plus 25 times 1. And if it's -1, it'll say plus 25 times -1, which is -25. So it'll put it on my other side. So direction has a couple of uses here. Let's go ahead and see how this looks. If you want to pause the video to catch up, if you're following along, and that's great, please pause the video now. I'm going to go ahead and select my level 1 scene tab right there. I will press play scene. And if I go ahead and press F or V on my keyboard, I am shooting a fireball. If I turn around, hey, look, it's right there. It's firing. That's great. If I jump up, I can shoot a fireball, but again, my game is crashing. I'll go ahead and press stop. Now, it's not bouncing yet, and we'll do that a little bit after a few steps, but I think what's more important than actually making the fireball bounce at this point is making it actually destroy enemies. So I have my code for shooting the fireball. If I go to my Steve's code, it is all right there for the most part, along with calling this fire function from both our floor state right there, as well as in our air state right there. And of course, we preloaded the fireball scene right here. Let's go ahead and take a look at our enemies. If I go back to my level 1 scene and I go and look at it, actually, I have 3 enemies in my scene. But of course, if I go to the scene doc, these are all just instances of the same reused scene. So I can just edit one enemy to make it be hurt by a fireball, and it'll update all the other enemies, of course. So I'm going to go into my enemy scene. I'll press this little clapboard. Doesn't matter which one I select. I click, and I can see how my enemy is constructed. Now, when we made these, I set up my collision layers and collision masks. If I select the root node, you can see under the second little collision section here that I made the enemy root node be on layer 5, which is on these ellipses right here, the enemy layer, and I made the enemy object, the root node, actually be able to detect, well, players and platforms, and if I hover over, fireballs. I actually don't want that. I don't want the root node object, the physics object, to be able to detect fireballs, so I'm going to actually turn that off. Actually, I'll press the little ellipses here and turn off fireball right there. Because my enemy has multiple parts and multiple areas for detecting other objects in the game. I have my actual physics object, which is basically this rectangle right here. That's its collision shape. I also have a top checker, which if I select that node, it's an area 2D. It's this object up top right here. It's for detecting if you jump on your enemy with your character. It's the top checker. If I select the top checker, can it detect fireballs? Yes, it can. That's layer 6 of the mask. So I'm actually going to turn that off as well. I'll turn off fireball because the only area that I'm going to have detect fireballs is the sides checker. This is where it checks to see if your character hits the enemy from the side. It can detect players and fireballs. I'm going to leave that. Now, one thing I'm going to change about this player structure, or the enemy structure, pardon me, is that I don't think this collision shape needs to be as tall. Like this shape right here, if I press Control Z, that was how it was before. I'm actually going to grab the top little pink handle and drag it down because I don't want the fireball to bump into this at all and hit the corner of it up there. So I'll just make it short. You want the bottom of this shape to line up with the bottom of the enemy, so the enemy still falls on the floor, but it doesn't need to be taller than that for the game to work, okay? So we have a little bit of an issue here. If we select this sides checker, the only thing in the scene that has this mask 6 layer, oops, I don't want to select that enemy. I don't want enemies to be able to detect other enemies. No. So it's the only thing that can detect fireballs. And that's a good thing. However, if I go to my enemy's code, I'll click on this little icon right there, and I go to the function called onSidesCheckerBodyEntered. This is what actually gets run using a signal whenever something, any physics body, enters that sides checker. First of all, it prints ouch, and I don't need that. That's just a little code that I used to check to see if this was working. I'm going to get rid of that. But what happens when any physics object hits the sides checker is it thinks that that physics object, no matter what it is, has a function called ouch on it. And our character, Steve, if I go to Steve's code here, actually does have an ouch function. It's right here, and it makes my character turn red and recoil and jump away and get hurt. Well, our fireball doesn't have that. So when a fireball hits that side checker, well, the program will crash because it's looking for that ouch function. So what I have to do here is use collision layers to my benefit. And there's many ways we could do this. What I'll basically do is say if, and I'm going to get the collision layer of the body, anything that's a physics object that collided with the sides checker. I'm going to say if get underscore collision layer, bracket, colon, and I'm going to put an equals sign here. We're going to check to see if the collision layer is equal to 1. And that is my player layer. If we hit, or if the body that enters the sides checker is Steve, my character, then sure, I'll press tab right there to indent that. We can call the ouch function on the character Steve. But this should only check and do that if the object is on the collision layer 1, which if I go and select my root node, layer 1 right here is the player. However, you should know that when you call the method get collision layer and you say equals 1, this is actually not the same as the layer number that we just looked at. If I go back to these layers, they're numbered 1, 2, 3, 4, 5, 6, 7, 8, etc. However, if I hover my mouse over these little buttons, you're going to see that they have a bit value and they have a value. And the button 1, the layer 1, has a value of 1. Go figure. Button 2 has a value of 2. Hey, it seems like a pattern. However, if I hover over number 3, layer 3 has a value of 4. Okay? And button 4 has a value of 8. And 5 has 16, and 6 has 32. These are powers of 2. 2 to the power 0 is 1. 2 to the power 1 is 2. 2 to the power 2 is 4. 2 to the power 3 is 8. And 2 to the power 4 is 16. And 2 to the power 5 is 32. So these are the powers of binary digits. If you count in binary, you know what I'm talking about here. Essentially, when you say get collision layer, you are not getting the number that you see on the button. You are getting the value of the binary bit that it's using to store these layers. It's a little confusing. If we want to check to see if a object is on the fireball layer, the value is going to be, or the collision layer using that method call is going to be 32. So what I'm going to do here is in my enemy's code, in that size checker body entered function, we can check for layer 1, which actually is the value of layer 1. However, I'm going to say, lined up with my if statement right here, I'm going to say else if, and then I'll say get collision layer is equal to 32, then I know it's the fireball. And what happens if the fireball hits the enemy's size checker? Well, I actually want two things to happen. I want to destroy or remove the fireball itself from my game. So I'm going to say body, that's the physics body that enters the size checker. I'm going to say body dot queue underscore free. And I'm also going to say, hey, I'm going to delete the enemy as well. So I'm going to say QUE_free as well. And you know what? I actually just realized I typed elsif right here. That's my Java coming through back to me. It's actually elif in GDScript, elif, not else if. So that's why it wasn't auto-completing my code for me, and I was typing it all manually up myself, and I wasn't sure why. I think that's why. Okay, so that should do it. So if I go ahead and press Control S to save, and I select my level 1 tab right there to activate that scene, and I press play scene, well, I can shoot fireballs, and if I shoot an enemy, hopefully that enemy is not disappearing. I'll go ahead and pause this video and find out why. Well, wouldn't you know it, it was a really silly mistake. When I am checking to see if the body has a collision layer of 1 or 32, checking to see the collision objects, collision layer, and using that collision layer of that body to determine what we do, well, I forgot to put body dot right there because we want to get the collision layer not of the object that we're currently on right now, which is my enemy. I want to say body dot get collision layer and body dot collision layer because that's what we're checking to see if it's on layer 1 or the value 1 or the value 32, not the code or not the object of the code that we're currently on. So that was a silly mistake. So now with this code, if I go ahead and press Control S to save and select my level 1 tab and press play scene, well, if I go ahead and mash that fire key on my keyboard, you can see the enemy disappeared. Does it? If I go ahead and fire, does it delete that fireball? I actually didn't notice, so I'm going to pause the video and check. And yes, it does. The fireball does disappear when it hits an enemy and the enemy gets killed as well. It disappears. So this code all works. We have a fireball that can destroy an enemy. However, the fireball does not bounce. So let's go ahead. I'll close my bottom output dock there. I'll go back to now my fireball code and I'll go ahead and maximize my workspace. In order for the fireball to bounce, we need it to have gravity. So I'm going to go ahead and make a new constant up at the top of my fireball's code called const gravity. And I'm going to make gravity equal to 22. That'll be the downward positive y force that gets added to 60 times per second in physics process delta. That's great. We're also going to make a constant called bounce. And this bounce is going to be the force that is upward on the fireball whenever it hits a floor. So we're going to make bounce equal to, and I believe I use -300. If I can remember correctly, that's about a good number. So 60 times per second in physics process delta, the very first thing I'll do is I'm going to push down on the fireball using gravity. So I'm going to say velocity.y is going to have it added to. So I'm going to say plus equals. Plus equals is how you add on a value to an existing variable. So whatever number I put over here will get added onto this variable here. I'm going to say gravity, just like that. So we're now adding gravity 22 onto the velocity.y, speeding it up over time. That's great. If I want it to bounce when it hits the ground or the floor, well, right under if is on wall, I'm going to go ahead and press enter and backspace. I'm going to say if is on floor, I want it to bounce. And so I'm going to say velocity.y. We're just going to give it the value bounce. We're going to overwrite any gravity speed and just say, hey, now you're going to move up really quick. But gravity will quickly overpower the bounce and make it kind of come up to a nice, bouncing stop or arc or speed that gets slowed down when it's moving up, and it'll speed back down, falling back down again. So I can just say equals bounce, just like that. And these are not supposed to be an if and an elif. They're just two separate ifs for two separate conditions. In fact, I'll go ahead and separate them just like that. Now, one thing we haven't done yet is actually make the Fireball Sprite spin. And that's an important part of a Fireball. So I'm going to, before I even push the Fireball down with gravity, we're just going to change the sprite rotation, and that's quite easy to do. If I go and look at my Fireball scene, I'll go into my Fireball scene right there. We're just going to access this $ sprite in our code and change its rotation property, actually its rotation degrees property, and just add to it 60 times per second to make it spin around. Okay, so in my Fireball's code, right before we actually start messing with the gravity, we're just going to say $sprite dot, and now I can access the sprite's properties if I say rotation underscore degrees. The rotation property, I believe, uses radians, which is a little bit harder to understand, I think, than degrees. So I'm just going to say, hey, make the degrees, add to it. So I'm going to say plus equals again. And I'm going to pick a number here. I'm going to say, 25. Except I want it to rotate 25 degrees again and again, or negative 25 if it's spinning the other way around. So I'm going to say times direction. So 25 or negative 25, and that should be pretty good. So I'll go ahead and press Control S to save, and I'll go back to my level 1 tab right there. I'll press play scene. And so now if I fire, hey, it's bouncing, it's spinning, it's looking great. If I fire that way, it's looking great. What happens if my fireball hits a wall? Well, let's go ahead and make a wall. I actually don't have one right now. If I go and look at my scene and I look at the side of this little platform here, this is not a solid wall. I can pass right through that, and so can my fireballs. So I'm going to select my tiles solid tile map here, and I'm just going to very quickly, using this palette over here, quickly select this green tile and just make some tiles here, and I'll make a little platform top and a little, I'll scroll down, and a platform top right there. So I'll hit the side of these because these are my solid tiles. These ones here are my one-way tiles, which have the no collision area right in the green one, so I can walk right through it. So now I'll press Control S to save my level. I've got a little extra platform here. If I press play scene, in fact, I'm going to select my root node again, so I don't have that grid up, my orange grid for my tiles up. If I press play scene, and then I face the wall and I shoot, well, my fireball knows that it's hitting a wall and it destroys itself because of its code. If I go to the other side of it and actually up close to it, there might be a little problem here. If I try jumping and firing, if I, for some reason, decided that I wanted to fire or start a fireball a little bit farther out from my body, recall that on Steve's code, I'll jump back to Steve's code, we said whenever we fire, I'll go back to my fire function here. I'll make this a little bit narrower on my screen, maybe zoom out a little bit so you can see all of this code. I picked the number 25. If I hadn't decided on that, I warned you about it. If you said something like 55, you might see a little bit of a problem. If I Control S to save and go to level 1 and press play scene, if I walk up to a wall and I fire, we get a fireball stuck in the wall. And I have not been able to solve this in an easy way to teach in this length of a video, but we will solve it in a future video. Essentially, you can't detect, I've looked into this, as far as I know, you can't actually look at the fireball's velocity and say, hey, if the velocity is stuck at 0, delete it. That doesn't seem to work. So we're going to actually stop in a later video Steve from firing a fireball in the first place if he's too close to a wall, and that requires we add another node into Steve and change the code a little bit. We're actually doing that anyways for a future video, so I'll leave that until then. For now, I'm just going to make sure it's a small enough number that that won't happen. Okay, 25 seems to work for me. Okay. Now, one thing that we haven't added into our fireball that's going to cause an issue if you shoot too many fireballs into your game is, well, I'll actually go ahead and play my game so you can see what I'm talking about here. I'll select level 1 and I'll press play scene. If I'm in my game and I'm, merely pressing the F or V key on my keyboard to shoot lots of fireballs into my level, and some of the fireballs are hitting walls and so they're being destroyed, but others are just in my game and they might fall off the edge of a platform and they might keep going forever. And so if a fireball happens to go down here, it's just going to keep going and keep falling and be in my game forever. And if I have too many of those, well, that could cause a problem. It could cause my game to slow down. So what I'm going to do is actually go into my fireball scene. I'll actually go and take a look at my fireball. And I'm going to add another node into this scene that detects to see if the fireball is actually on the screen. Now, all fireballs should be made originally within the bounds of my game's window. So if they go out of those bounds and too much out of those bounds, I just want them to automatically delete. You can do this by adding what's called a visibility notifier a node into your object that you want to have delete, and then you can use a signal which will just say, hey, delete me if I go off the screen. So in my Fireball scene, I'm going to select my root node. I'm going to press plus. I'm going to do a search up at the top for visibility or visib, and it'll find it. It's called visibility, and there's two of them, notifier and enabler. We're going to use the notifier one. We want to be notified when this goes off screen. So I'll double click on that. It becomes a child directly of the root node, so lined up with these. And it is a shape. So I can actually drag the edges. In fact, I'm going to press Control Z. I'm going to hold Alt on my keyboard, or Option on a Mac, I believe it is. And I can drag an edge, and it'll, with the Option or Alt key held down, it'll scale out from the middle. If you don't, it'll just scale to one side or the other. So I'm going to hold Alt. I'm going to make this shape quite wide compared to the Fireball, and I'll hold Alt and drag again. Not quite as tall, because the game is more widescreen and you travel left and right more than you do up and down. So if this area, this visibility notifier, goes off the screen, I want it to emit a signal to the Fireball's code. And then when that signal is emitted and that method or function gets called, I want the Fireball to get deleted. So with that visibility notifier 2D node selected, I'm going to go over to my node tab here. These are my signals. I'm going to go ahead and double click on screen exited right here. Double click. And I'm going to select my Fireball root node right there with the script file on it. And it's going to make a receiver method called onVisibilityNotifier 2D screen exited. That's fine. So everything default here. I'll press connect. It makes this function or method down here at the bottom, and it doesn't have any code except for pass. We're going to get rid of that. This is the code that gets called whenever it goes off the screen. I'm going to say, if that happens, hey, delete this one. Q, free, bracket, bracket. That's it. Pretty simple. Now, if I go ahead and press Control S to save, and I go ahead, I actually won't be able to tell because it'll be off the screen when it happens. But if I press play scene and I shoot some fireballs, when they go off screen, they get destroyed, and that's a good thing. Last but not least, we want some sound. So I'll go over to my Fireball scene. I'm going to select the root node. I'm going to go ahead and add, I'll press the plus with the root node selected. I'm going to add two things, actually. I'm going to add a timer node. We've used these before. And I'll select the root node again, and I'll press plus. I'm going to add an audio stream player, not 2D or 3D, just the normal audio stream player, because I'm actually going to have the Fireball play a sound, but I'm going to have it wait a fraction of a second before it starts playing that sound in case the Fireball hits a wall really quick. Okay, and I'm being picky here, but I think it works better. If you're standing right next to a wall and a Fireball gets spawned and it plays a sound, and I'll go back to my level 1, and you're standing basically right over here, you don't want the whole sound to keep playing or just blip. You would rather just have the Fireball not play a sound at all. So I'm going to make this a little bit harder on myself. I'm going to say, hey, my timer, I want my timer to be a one-shot timer. I'm going to make my timer's wait time equal to 0.05 seconds. And I'm actually going to have this timer auto start. So when this scene first loads into my game, the timer will start. It'll only count down once, and it'll only count down a fraction of a second. And when it finishes, I'm going to go ahead and go to the node tab here with the timer selected and say when it times out after a fraction of a second, well, I'll double click on this signal. I'm going to select the Fireball root node. It's going to make a new receiver method called onTimerTimeout. That's fine. I'll press connect. And when that timer times out, we're going to call the audio stream player's play function to play its sound. So I'm going to call the $. I'll go ahead and replace this code with $ audio stream player. That'll access this node, and I can say dot play bracket bracket. That'll go ahead and play it, except we haven't actually given it a sound yet. If I select my audio stream player node and go over to the inspector to look at its properties, the stream, the actual sound, is empty. We're going to go down to our file system doc to our assets folder. Earlier in this video series, I gave you some sounds to work with. I believe that was when we added the sound effects to our game earlier. We got some sounds in our sounds folder, and I believe the sound that I use in my game for firing a fireball is actually called minimize001. It's an OGG file. If I go ahead and double click on that, it opens that sound up in my inspector. And if I go ahead and press play, Well, that's how it sounds. It loops. I can turn looping off temporarily right there. If I press play, that's what it sounds like. So we're going to actually turn loop off more permanently than this. You can't actually do it here. It says changes might be lost. You can't update file settings right here. You have to select the file over here in the file system dock, go up to import for a sound, and then under import with that file selected, turn the loop off and then press the re-import button. That's how you do it, not over here. Okay, we don't want the sound to keep looping again and again. When you fire, it's one sound per fireball. So we have that sound. If I go back to my scene dock and I select the audio stream player, we're going to adjust the volume. It's way too loud right now. I'm going to turn it down to -25 decibels, I think should be okay. And I'm actually going to change the pitch scale as well. I want it to be 0.8. I think it's a bit too high pitched right now, so this should make it a little bit lower. That looks pretty good to me. If I go ahead and drag minimize 001 into the empty stream, I'll go ahead and press Control S to save. I'll go back to my level 1 scene and I'll press play scene. So now if I press F to fire or V to fire, it plays a little sound. I think the volume isn't too bad on that. And if I fire, you can see it gets cut off. And if I'm right next to the wall, I don't even hear the sound. And that's because of that little delay that we added with the timer. That looks pretty good to me. So now I have fireballs in my game. It's done. That will be it for this video. Thank you so much for watching. If you made it all the way through this video, it means a lot to me, and I'm glad you're following along in this series. There will be more videos in this series continuing on making this 2D platformer game. As always, my name is Colin. If you like this video or if you learned something in it, please go ahead and click on that like button below. It really helps out me and my channel. And if you want to see more videos like this one in either Blender or in the Godot game engine, click on that subscribe button and the bell icon to be notified whenever I upload a new tutorial. Check out my Facebook page and my Instagram page. In those two places, I post sneak peeks and previews on what I'm working on next, so you'll get a sneak peek of what's coming up here in my channel. But that'll be it for this one. Thanks again for watching. I'll see you in the next one. Bye-bye.